Okay, so what we're going to do is start a new unit, and in this unit what we're going to do is look at chemical reactions. So you could argue that chemical reactions are the essence of high school chemistry. In September, if I had asked you what do you think high school chemistry is, most of you would say something about taking some chemical, putting it in a beaker, maybe some Bunsen burners, and doing something like that, making something. Things bubbling away, things reacting, things making smoke, etc. So anyway, what we're going to do is explain how we write or how we represent a chemical reaction by writing a chemical equation. So when we talk about chemical equations, what we mean is you take a few chemicals, and in this case we'll take hydrogen and oxygen, and they rearrange themselves and form a new product. So on the on the left-hand side, we refer to those things as reactants, and then what they become is what we call products, and that should be information you already know. The arrow, as you know, sometimes means reacts to form, sometimes we say yields. Basically what you want to know is that arrow is the divider between what the things were in the beginning and what they become in the end. As we move through this unit, we'll talk about something called catalysts, and if there is a catalyst in a reaction, you typically write it over the arrow. So for this reaction, that symbol stands for platinum, so we would say that this reaction is catalyzed by platinum. Now we'll talk about the definition of catalyst in more detail later, but basically what a catalyst will do is make this whole process happen faster. So catalysts speed up chemical reactions, but they're not involved in the actual reaction. They're not forming bonds and involved in forming the products. Okay, so what a chemical equation is going to do, and here let me write the one we were using. So what a chemical equation is going to do is explain what is happening on a chemical level. When we say that, what we mean is this hydrogen is going to break apart into two hydrogen atoms. This oxygen is going to break apart into two oxygen atoms. And then what's going to happen is these chemicals or these substances are going to reform into a new compound. And in this case, we're going to take a hydrogen bonded to an oxygen, put another hydrogen there, so we've got a new water molecule. And we'll talk about what happens to that other oxygen a little bit later. So anyway, it's important to understand that what we are representing here in a chemical reaction is chemical changes. Bonds are being broken and bonds are being formed to produce something new in the chemical reaction. What's important to understand is that the properties of the new compound, in other words water, have nothing to do with the properties of the reactants. In other words, the properties of hydrogen being lighter than air, being a gas, being combustible, don't have the same properties as the thing it helps to form, which is water. In other words, a liquid at room temperature, denser than air, etc. Physical properties or physical changes are when you just do something to the compound without changing it chemically. So if we had our water in a beaker and we boiled it and turned it into steam, it's still a water molecule, it's just in the gas phase instead of the liquid phase. So physical changes, you're just altering the appearance of whatever it is you're talking about. Chemical changes, you're actually producing a new compound. Okay, so let's start to write some chemical equations. What we have here is the written form of the equation, and what we want to do is write it out in symbols and numbers. So I'm not going to talk about naming. I'll assume at this point you know how to write formulas, and if you don't, I would recommend going back and looking at some of the older vodcasts or simply asking me in class. Please disregard the coffee maker gurgling behind me. Okay, so lithium chloride reacts with sodium sulfate to form lithium sulfate and sodium chloride. So all of these are formulas for substances or compounds, and all of them are formed by knowing the charges and crisscrossing. So IDE ending, single element chloride. The charge on lithium is 1 plus, the charge on chlorine is 1 minus, so when we crisscross it's a 1-to-1 ratio. Remember, ATE endings mean polyatomics. The polyatomic sulfate is SO4 with a 2 minus charge. Sodium is 1 plus, so when we crisscross, that 2 goes behind the sodium, etc. Alright, if we look at the next one, we have simply iron, and that's just the element iron. It's not diatomic, so don't put a 2 there. And that's going to react with oxygen. Oxygen is a diatomic, and remember, diatomics by themselves, we put subscripts of 2, and that's going to yield iron 3 oxide. Now remember, that 3 means iron with a 3 plus charge, oxide 2 minus charge, so when we crisscross, Fe2O3. For the third one here, I would need to tell you that silver has a 1 plus charge, and since nitrate is 1 minus, when we crisscross it's a 1-to-1 ratio. Hydrosulfuric acid, H and one other letter, producing silver sulfide and nitric acid. So there's nothing really new here. Basically all I'm doing is I'm writing formulas, which we already know how to do, and I'm just putting the reactants on the left side and the products on the right side. So what we're going to do is talk about how we balance these equations using the law of conservation of mass. So let's move on to do that. Okay, we talked about the law of conservation of mass earlier this year, and we defined it as basically matter can not be created or destroyed. Atoms simply rearrange to form new compounds. So what this means is when we have two things available, for instance, in this case we have hydrogen and oxygen. Again, hydrogen is made up of 2 hydrogens, oxygen is made up of 2 oxygens. The only thing we can do with these things is break them apart and have them reform into new products. So we started with 2 hydrogens, we ended with 2 hydrogens. We started with 2 oxygens, but we only have 1 as a product, so we have to account for our missing oxygen. And we do that using law of conservation of mass. The basic idea is every atom has a certain mass, and you know that from the periodic table. We called that molar mass. So if we can't lose or gain mass, what we have to make sure is that we have the same number of each atom or element on each side of the equation. And when I say side, I mean from the arrow. So we have to have the same number of hydrogens over here that we have over here. So to do that, what we're going to do is balance these equations. And we're going to balance them using coefficients here. So let's move to a cleaner slide. We're going to write this reaction and then we will balance it. Okay, so let me write my reaction. H2 plus O2 yields H2O. So the only thing that we can do here to balance this equation is put numbers in front of our compounds. So again, when I say balance, what I mean is I need the same number of each element on the right side as I have, I keep calling that right side, on the left side as we have on the right side. So our subscript is going to tell us how many of each element we have. So for instance, here we have 2 hydrogens. Over here we have 2 hydrogens, so that's good. They balance. Here we have 2 oxygens, but over here our subscript is 1. Remember, when we don't have a subscript, it's implied that it's 1. So we have 2 oxygens on this side, but only 1 on this side. So what we need to do is we're going to put a 2 in front of this water. That 2 we call a coefficient. And what coefficients do is they do two things. They multiply subscripts and they distribute throughout the formula that they're in front of. So for instance, here we would have 4 hydrogens and 2 oxygens. So the oxygens are good. We've got 2 there and 2 there, but now we've changed the number of hydrogens. We have 4 on the right, so what we have to do is put a 2 in front of that hydrogen, so we have 4 on the left. When you're done, just go back and check everything. 2 times 2, we have 4 hydrogens. Over here we have 4 hydrogens. 2 oxygens. 2 times 1, 2 oxygens. So everything balances. So what you have to remember is that you need the same number of each element on the left as you have on the right, and you can put coefficients in front of compounds to balance them. Never ever change the subscript. As you know, subscripts are determined by the formula. So for instance, with water, 1 plus, 2 minus, the reason there's a 2 there is because when we crisscross, it's H2O. So only put coefficients out front. Never change the subscripts. In the next vodcast, what we'll do is go over a bunch of practice problems. So in your practice packet, we will go over the first lesson practice problems.